Okay, ladies and gentlemen of geometry, 7.4 talks about an inscribed angle. Inscribed angles are a little bit different than central angles, so let's kind of talk about what those are. Okay, an inscribed angle goes like this. An inscribed angle basically says that it's an angle in a circle where the vertex is on the circle. Okay, and the sides contain chords of the circle. So basically, it's an angle that is entirely encompassed in a circle. And the intercepted arc is much like a central arc. It's going to be right here. So, arc with the endpoints on the sides of an inscribed angle and lies on the interior of the inscribed angle. So basically, it's on the inside of this angle. So that's what an intercepted arc is. So now before, we talked about a central angle. So, okay, a central angle looks like this. So, if this was 40 degrees, this was 40 degrees. Okay, the central angle matches up. In an inscribed angle, it's actually 1/2 of that. Okay, so if this is going to be 70 degrees, this angle is going to be 35 degrees. All right, if this is, 90, then this is going to be 45. So in this angle, an inscribed angle is going to be half of the arc measure. So if I'm looking here, this is 56, this is 70. Angle P, well, I found it, it's right here, but I think they want the measure. The measure is going to be half of this arc, so that makes that 35. Figure out PQ. Well, PQ is this arc, and this angle is half of this arc, so that means this arc is going to be double. So I'm going to take 56 times 2, so that's going to be 112. So taking a look, figuring out angle C. Angle C comes from this arc, so that's going to be 98 divided by 2, so that's going to be 49 degrees. Arc CF is this one right here. This is coming from the 40 degrees, so that's going to be 80 degrees total. So, if two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So basically what this is saying is that if I've got a inscribed angle, but I've got another point that intersects the exact same thing, these two are going to be equal. Okay, so let's kind of clean this up a little bit. So let's call this, we'll go A, B, C, and D. So basically what this is saying is angle B and angle A both intersect arc DC. So because they do that, that means that angle B is congruent to angle A. They both intersect this same arc, they're going to be congruent to each other. So look in here, angle T hits this, angle U hits this, so I'm going to say 3x minus 5 is going to be equal to 2x plus 15. Now a little algebra, I get x equals 20. But they don't want what x is, they want to figure out what t is. So I'm going to take 3 times 20 minus 5 and get 55. That's my answer. All right, so now number 6. If s is 3x and v is x plus 18, figure out what angle s is. Okay, so let's clear this up a little bit. Okay, so this is 3x, v is x plus 16. Now, they both intersect this little arc, so yeah, they're going to be equal to each other. So a little algebra. X is going to equal 8. So figure out what s is. S is going to be 3 times 8, so 3 times 8 is going to be 24. There's my answer. So an inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is the right angle. So on some level, I'm kind of hoping this makes sense, because if you look, if this is a semicircle, a semicircle would be half a circle, which would be 180 degrees. So if I've got this intercepted arc is automatically half of that. So that's going to be 90 degrees. Well, 90 degrees is a right angle. So it kind of works both ways. So this is a right angle. That makes this a semicircle. Okay, that makes this a diameter. And then flip it around. If this is 180, or if this is a semicircle, then this is also a right angle. So if I take a look, now look, angle G intersects this. Okay, this is diameter, this is a semicircle, so that means angle G is going to be 90 degrees. Okay, this is 180 degrees because it's a semicircle. This FH is a diameter. So figuring out the angle of F, here's what I got to do. It's still a triangle, and it's going to add up to 180. So I'm going to have 4x plus 2 plus 9x minus 3 plus 90 equals 180. So, putting together these terms here, that's going to be 13x plus 2 minus 3 plus 89 equals 180. So 13x is going to equal 180 minus 89, which would be 91. 91 divided by 13 is going to be 7. So now, what do they want to know? They want to know, figure out F. So F is 4x minus 2, so that's 4 times 7 plus 2 is going to be 30. So F is going to be 30 degrees. So in a quadrilateral, the opposite angles are supplementary. Supplementary way back to Unit 1 word there, that just means adds up to 180. Which should make sense because, okay, let's look at something here. If I look at KL and KN, this angle, it intersects all of this. Okay, now if I flip it around, if I look at ML and MN, that cuts all this. So between the two of those, they cover the whole circle. All right, between angle K and angle M, they have that whole circle. Well, a whole circle is 360 degrees. These are inscribed, so that means between the two of them, you have to divide it by 2, so that means they add up to 180 degrees. So that means between this angle and this angle, you've got the whole circle covered. That means that those two angles have to add up to 180. So figure out A and figure out B. So taking a look here, this is going to be 2x minus 30. This is going to be x. So between the two of them, so that's going to be 3x equals 210. So x is going to equal 70. So if this is 70, 14, that's going to be 110. That's 90. This is 90. So A is going to be 90. B is going to be 110. But all I did was figure out that opposite angles have to add up to 180. So figuring out x and y, same kind of idea. 60 and the opposite have got to be 180. 95 and the opposite have to be 180. So 60 plus x equals 180. So x equals 120. 95 plus x, that's a 5, equals 180. So x has got to be 85. Or sorry, y has got to be 85. So this is 85. X is going to be 120. There's my answer. Okay, that's all I got. Come talk to me, play around with this, and let's see what you can put together.